Okay, as we finish up example 1, we got to the point where we said we've got our x-intercepts, we've got our y-intercept, we have our asymptotes. Now we start plugging in values for x. We want to plug them in to either our original function or once we've factored, whichever is easier for you. It makes no difference. So when we do, we always want to make sure that we pick at least 2 values to the left and right of each vertical asymptote. It's also good to pick points between your x-intercepts and between your x-intercepts and asymptotes and between asymptotes. So let's pick 2 numbers to the left of this x-intercept, and it makes no difference. I'm just going to go ahead and choose -4 and +1, because why not? Or excuse me, -4, and that would be over on the left. Now, +1 is going to give me a point in between those 2 x-intercepts, just to give me an idea of what's happening. And then I'm also going to pick something between this x-intercept and this asymptote, which doesn't leave me a lot of room, but I will go ahead and plug in 2.5. Again, just so we have an idea of what happens. Remember, at that asymptote, our graph is either going to shoot upward or shoot downward, and we don't know which direction yet. And then that takes us to our asymptote, our vertical asymptote at x equals 3. We keep moving to the right, we can plug in 2 more values. I don't know, 4 and 9 sound like good numbers. Plugging in -4, we end up getting the fraction 24 over 49. Now, for the sake of graphing, we can call that pretty much about 0.5. So then I plot that point, I move left 4, up 0.5, pretty much. So that takes me right about there. And then plugging in 1, I actually end up getting -1 over 4, or -1/4. Now, that's going to place me about right there. So already we can kind of tell that something funky is happening, because we hit this x-intercept and then go down and bounce right back up to this x-intercept. So we have to figure out whether our graph is going to shoot upwards like this or shoot downwards like that. And the only way to find out is by plugging in points. So by plugging in 2.5, we actually get +5. Again, just plugging it into our function. So when we have that point, that's going to tell us that our graph is shooting upwards. Now, our graph still levels off at our horizontal asymptote, so it just does it like that. It crosses through it at that point. That's okay. We never said that our graph couldn't cross our horizontal asymptote. And yesterday, our functions were a little bit more predictable. Today, less so. So now we just have to plug in points to the right as well and see what else is happening. So plugging in +4 into our function, we actually get +8. So we've got a point all the way up here. And then plugging in +9, just because, we end up getting 7 over 4, or 1.75. So that takes us about here-ish. So that tells us that our other portion of our graph is a little bit more predictable and looks a little bit more like the branches we saw yesterday. So there's our first rational function, kind of fun looking. In example 2, or I guess example B, whatever, I want to take a look at what my horizontal and vertical asymptotes would be first. So considering my horizontal asymptote, remember we have the 3 cases, and for this one, our degree on top is 0, right? Because we could also call this 6 times x to the 0th. Well, anything to the 0th power is just 1. So I have 6 times 1, which is 6. So sure enough, my degree on top is 0. My degree on bottom is 2. So the degree on top is less than the degree on bottom. So automatically I have y equals 0 for a horizontal asymptote. So I'll draw that in. Now, when I consider my vertical asymptote, I find my vertical asymptote by setting my denominator equal to 0. X squared plus 1 equals 0. But when we start to solve by subtracting 1 from both sides, we notice that we're going to get imaginary solutions, right? X would be the plus or minus square root of -1, which we know to be plus or minus I. Well, we can't plot that on the real coordinate plane, right? We know we can do it on the imaginary or complex plane. But in terms of a real coordinate plane or a real graph, no, I'm not going to have any vertical asymptote. Well, that's good news and bad news. The bad news is that doesn't give us a whole lot of information about our graph. Good news is no vertical asymptote. That's always fun. So now we consider our x-intercept, which remember we find by setting our numerator equal to 0. Well, if we remember that our numerator was just 6, can 6 ever be equal to 0? No. Well, that means that we have no x-intercepts. Okay, still not very helpful. What about y-intercepts? To find my y-intercepts, I'm going to plug in 0 for x. So I have y equals 6 over 0 squared plus 1. Oh, thank goodness. I have a y-intercept at y equals 6. So I go up 6, plot that point. Okay, got that. Well, from here, we're just going to plug in points. So we plug in, I would say 2 numbers to the left of that, the only point we have, and 2 numbers to the right, just to see what happens. So maybe let's go, whoopsies, -4, -1, and then I already have 0. And we'll go +1 and +4. Again, I'm just kind of choosing these points at random, but we for sure want 2 to the left, 2 to the right. Plugging in -4, we would have 6 over -4 quantity squared gets me a +16 plus 1. I have 6/17, which is very, very small. Plugging in -1, I have 6 over 1 plus 1 is 2. 6 over 2 is 3. Okay, now notice that when we squared those negative numbers, they became positive as well. So I have 6 over +1 plus 1, because 1 squared is still 1. So I have another point at the y-coordinate of 3. I'm plugging in +4. 6 over +4 squared is still +16. So I have the point 6/17 again. Now, in terms of a decimal, 6/17 is less than 1, which is honestly all we care about. So we have enough to plot. So -1, 3, and +1, 3. And then -4 and something less than 1. And +4, something less than 1. Oops, that's 5. Now, with that, we can kind of start to see our graph take shape. Now, these graphs will always be smooth curves, so that tells me that I don't want to like create a pointy top to this graph, but instead it's going to be relatively smooth, and it still has the horizontal asymptote, so we know it's still leveling off at y equals 0. Our graph ends up looking like this, and again, anything goes, anything can happen.